Cambridge Assessment International Education General Certificate of Education Advanced Level Higher 2 Paper 1. We want to solve all problems of this exam. Also, I will release the other exams, paper 2 other years. It is for 2021 H2. If you want to have next videos, subscribe my YouTube channel, turn on the bell now to have next videos. Also, if you had any question about the solutions or wanted the solution of other exam, other years, Olympiads, A level, anything, as I said before in my other videos, feel free to send message to my WhatsApp number in the description and comments. A function f is defined by f of x equals ax cubed plus bx squared plus cx plus d. The graph of y equals f of x passes through the points 1, 5. It means what? If you replace x with 1, f of x will be 5. So the first equation we have a plus b plus c plus d equals 5. And negative 1, negative 3, x negative 1, negative a plus b, negative c plus d equals negative 3. The graph has a turning point and at x equals 1. Okay, turning point at x equals 1. So if we consider f prime, it means f prime 1 is 0. F prime x equals 3ax squared plus 2bx plus c, and we know this term equals 0 for x1. So 3a plus 2b plus c equals 0. And it says if, okay, now, and antiderivative of f of x evaluated from 0 to 1 equals 6. So if we consider this is what? It is ax cubed plus bx squared plus cx plus d dx equals ax 4 over 4 plus bx cubed over 3 plus cx squared over 2 plus dx from, let me say, we calculate this, evaluated from 0 to 1. 0 it will be 0, and for 1 it will be a over 4 plus b over 3 plus c over 2 plus d. It equals 6. So let's write the fourth equality plus d equals 6. We can multiply the last equality by 12. So 3a plus 4b plus 6c plus 12d equals 72, and it is exactly this. Let's erase this part. You can solve it with several ways. Let's move it here. Okay, one way is replacement. If you add up these two equalities, we have 2b plus 2d equals 2. So b plus d equals 1. And then you can replace, you can say, okay, d is 1 minus b. Then we reach easily 3 equations, 3 variables. The first one will be a plus b plus c equals, you write on. From first one, you say, okay, b plus d is 1. We can say it's better. B plus d is 1. So you say, okay, from first one, a plus c is what? Is 4. Okay, from second one, b plus c is 1, a plus c is 4. So you see they are equivalent. And this one is 3a plus 2b plus c equals 0. And from last one, if we replace d with 1 minus b, then we have what? 3a, 12 times minus b minus 12b plus 4b, which will be minus 8b plus 6c equals what? 12, that is 72 minus 12, which equals 60. Now we have 3 equations, 3 variables. From this one, you say, okay, c is 4 minus a. So if we replace, we have 2 equations, 2 variables. You say, okay, it is 4 minus a, so it will be 2a, because minus a plus 3a, 2a, plus 2b equals negative 4. because it is 4, take it right hand side. And then you can conclude a plus b is what? Is negative 2. If you replace here, c is 4 minus a, so negative 6a plus 3a, negative 3a minus 8b, and plus 24 equals 60. So you can take 24 right hand side, and it will be 60 minus 24 will be 36. Now we have two equations, two variables. Here you replace b with negative 2 minus a, and here we can say, okay, negative 8 times this. We have 8a, 8a minus 3a, 5a. Negative 8 times this, 16, and 36 minus 16, 20. So we can easily find the variables. A equals 20 over 5, 4. B equals negative 2 minus a, negative 2 minus 4, negative 6. C will be what? 4 minus a, 4 minus a, which will be 0. And D equals what? 1 minus b, which 1 minus minus 6, 1 plus 6, 7. Okay, so we found all the variables A, B, C, D, and the problem wanted this. If you had any question about the proofs or other things, as I said before, feel free to send a message to my WhatsApp number in the description and comments. Cambridge SSM International Education H2A Level Paper 1 2021 Problem number 2 Part A. Sketch on the same axis the graphs of y equals absolute value of x squared minus 5 and y equals 2x minus 1. 2x minus 1 is a line, and x squared minus 1 you can at first draw completely and then consider absolute value. So this part is negative in x squared minus 5. You should consider the positive one. And then if you draw, you will see these two things also. If you want to find x-intercepts, you say, okay, x squared minus 5 equals 0, so x squared equals 5, so x equals plus minus root 5, which are these points 2.236 and negative 2.236. And for y equals 2x minus 1, it is a line. You need to only consider 2 points. If it is 0, it is negative 1. If it is 1, it will be 2x minus 1 will be 1. And as you can see, we have two intersections. Okay, for part B, it says find the exact solution of absolute value of x squared minus 5 equals 2x minus 1. We should find intersection. As you can see, let me show with red. We have two intersections here. And let's solve these and find exact coordinates. So it will be what you say, okay, if x squared minus 5 is greater than equals 0, then x squared minus 5 equals 2x minus 1, and then x squared minus 2x minus 4 equals 0, so x equals negative, so x equals negative b plus minus b squared 4 minus 4ac, which will be 16 over 2. And if it will be 20, if you divide by 2, it will be 1 plus minus root 5. And if we check 1 plus minus root 5 squared minus 5, it will be 1 plus 5 minus 5, 1 plus minus 2 root 5. And we see only plus works here, because if you consider negative, it is at least 4. Negative is 4 at least, and negative 4, it will be negative. So here we consider 1 plus root 5, the x coordinate, and if we replace here, for example, it will be 2 times this minus 1. It will be 2 root 5 plus 2 plus 1. It's the first point, and the first one will be 3.236, and second one, if you calculate, it will be 5472. Okay, so let me show it on the diagram. 3.236. Here we said x squared minus 5 positive. This one 3.236 and 5.472. This is this intersection. Now let's consider the case that x squared minus 5 less than 0. So here we conclude 5 minus x squared, because it is negative, equals 2x minus 1. If we take all things to right hand side, it will be x squared plus 2x minus 6 equals 0. And then we can say x equals negative b plus minus b squared 4 minus 4ac, which will be 24 over 2a. And it will be negative, if you divide by 2, it will be negative 1 plus minus 28 over 2, which will be root 7. And if we replace here, it will be negative plus minus root 7 squared minus 5, which will be 1 plus 7, 8 minus 5, 3. 3 here, it will be negative, because we have negative, negative, positive 2 root 7. It should be less than 0, so we can only select 3 minus 2 root 7, this one. It means we should select plus here, so x will be minus 1 plus root 7, and y will be what? 2x minus 1. It will be 2 root 7 minus 3. So x will be 1.646, and y equals 2.292 if you use calculator. Then let's copy this, and it is exactly this point. Okay, so we found the two intersections of this problem number. Cambridge Assessment International Education 2021 A level H2 paper 1 problem number 3. A curve has equation x to the power of 1 over 2 plus y to the power of 1 over 2 equals 3 for x and y that are positive. Show that dy by dx equals negative y over x to the power of 1 over 2. So we should differentiate y with respect to x of this equality. The first one will be 1 over 2 x to the power of 1 negative 1 over 2 plus 1 over 2 y to the power of negative 1 over 2 dy by dx equals 0. Now you can multiply both sides by 1 by 2, and you can take this to right hand side. It will be what? It will be y negative 1 over 2 dy by dx equals x power of negative 1 over 2 negative, because you take it to right hand side. And then we can conclude dy by dx equals negative x power of 1 over 2 over y to the power of negative 1 over 2. And it will be negative y to the power of 1 over 2 x to the power of 1 over 2. It will be negative y over x to the power of 1 over 2. In part B, the problem says find the equation of the normal to the curve at the point where x equals 1. So you use this derivative, you replace x with 1, and we should use main equality. Let me copy this one. So if x equals 1, we should see y equals what? X equals 1, then y to the power of 1 over 2 equals 3 minus 1 equals 2. So if we raise both sides to the power of 2, y equals 4. Now if we want to find dy by dx equals negative 4 over 1 half, it will be negative 2. Now the gradient of normal will be this times this must be negative 1. It will be 1 over 2. And we have one point of that. The point is what? 1, 4. And the gradient is this. So you know y minus y, for example, 0 equals 1 over 2 x minus x 0, this point. And so if we simplify, it will be y equals 1 over 2x minus 1 over 2 plus 4, and it equals 1 over 2x 4 minus 4 times 2, 8 minus 1, 7 over 2. So the answer is this. Cambridge Assessment International Education 2021 H2 paper 1 problem number 4, don't use a calculator in answering this question. The complex number z is given by this equality. Find part A, find absolute value of z and arc z, hence find the value of z squared. So we know EI theta, let me show with blue, EI theta equals cos theta plus I sine theta. This is an important formula if you want to use that here. Theta is what? Pi over 16. So it will be E to the power of I pi over 16 squared. And this one you can say the theta here is negative pi over 8 because you can take negative inside, and it will be E negative I pi over 8. Okay, so here if we simplify, it will be A I pi over 8 over E negative I pi over 8. It will be E to the power of this minus this. It will be plus, it will be I pi over 4. Now, absolute value of Z will be 1. Arc Z will be the angle pi over 4. And Z squared equals EI pi over 4 squared, which will be EI pi over 2. You can also imagine this on the axis here. So it will be what? It will be this point, which is I. So it equals I. Part B, again, we use the formula. We write it is EI theta times, you can say it is 1 plus E negative I theta. And it is left hand side, so let's write left hand side. If we multiply, it will be EI theta plus 1. EI theta is cos theta plus I sine theta plus 1, which is right hand side, and we proved this part. Hence or otherwise find the value of 1 plus z to the power of 4 plus 1 plus conjugate of z to the power of 4. Here, the first one, you can say, okay, because from first part we know z is what? Absolute value of z equals 2. So z squared equals I. We can conclude that because absolute value of z is 1, z conjugate equals z squared. Absolute value of z squared, which is 1. So you can here say y equals z times z conjugate plus z to the power of 4 plus 1 plus conjugate of z to the power of 4. Here we factor from z, it will be z to the power of 4, z conjugate plus 1 to the power of 4 plus 1 plus conjugate of z to the power of 4. And we factor from z conjugate plus 1 to the power of 4 times z to the power of 4 plus 1. Okay, now we replace z here with the answer that we found in this point. Z equals EI pi over 4. Z equals EI pi over 4. So conjugate of Z equals E negative I pi over 4. So first one, we write here what? We write Z conjugate plus 1 to the power of 4. If we replace here, or let's replace Z conjugate with this E minus I pi over 4 plus 1 to the power of 4. Z4 is what? Is EI pi plus 1. EI pi is what? If you consider, it will be negative 1 because it is the angle is pi and here is negative 1. So it will be negative 1. Negative 1 plus 1 will be 0. 0 times this equals 0. So the answer of this part equals 0. Cambridge Assessment International Education A-Level Paper 1H2 2021. Problem number 5, part A. Express x over x plus 2 times x plus 3 times x plus 4 in partial fractions. So I consider it is f of x. And I say, okay, f of x is a over x plus 2 plus b over x plus 3 plus c over x plus 4. Now I multiply x plus 2 by f of x and replace it with x equals negative 2. It will be what? This part will be x plus 2 will be cancelled. It will be negative 2. Negative 2 plus 3 will be 1. Negative 2 plus 4 will be 2. Times. If you multiply x plus 2 here and replace x with negative 2, it will be 0. And here it will be what? It will be a here. Now we conclude that a is negative 1. Similarly, we multiply x plus 3, f of x equals negative 3. Here you can say it is b, and if you multiply x plus 3 and replace x with negative 3, it will be negative 3. Negative 3 plus 2 will be negative 1, and negative 3 plus 4 will be 1. It will be 3. So b is 3, and the last part, if we multiply x plus 4 by f of x and consider x equals negative 4, it will be c here because they will be 0. And here it will be x negative 4, negative 4 plus 2, negative 2, negative 4 plus 3, negative 1. And it will be negative 4 over 2, negative 2. So it will be negative 1 over x plus 2 plus 3 over x plus 3 minus 2 over, or you can say plus negative 2 over x plus 4. Part B says find some of them from r equals 1 to n. So you say we replace here negative 1 over x plus 2, it will be sigma r 1 to n, negative 1 over r plus 2 plus 3 over r plus 3 minus 2 over r plus 4. And we have these terms. So if you write, for example, for first one, it will be what? Negative 1 over 3 plus 3 over 4, negative 2 over 5. And then replace r with 2, negative 1 over 4 plus 3 over 5, negative 2 over 6. Next one. Negative 1 over 5 plus 3 over 6 minus 2 over 7. Now, if we consider the 5 fractions, all of them will be cancelled like this. And we write, okay, for example, negative 1 over 6 plus 3 over 7 minus 2 over 8. Again, they will be cancelled. And if we write until n, it will be negative 1 over n plus 2. Let's do something. For example, if we write like this, it will be negative 1 plus n plus 2 plus 3 over n plus 3 negative 2 over n plus 4. So it will be cancelled, and if we calculate, we have negative 1 over 3 plus 3 over 4 minus 1 over 4. We have 3 terms that are left here. Also here it will be plus 3 over n plus 3 minus 2 over n plus 4, also the previous terms. Because if you want to see exactly it is what, let me explain. If we have this term, the previous one will be negative 1n plus 1 plus 3n plus 2 minus 2n plus, let me write n plus 2, n plus 3, and it will be negative 1 over n plus 3 over n plus 1 minus 2 over n plus 2. They will be cancelled, and if you want to see what is left, it will be 3 over n plus 3 minus 2 over n plus 3 minus 2 over n plus 4. So if I want to write minus 2 over n plus 3. So here, but n must be at least some number. N should be at least 3. To write these 3 terms, then you have 3 terms here, 3 terms here. So we consider it is for n at least 3. For n1 and n2, we check. If it is not equal, we calculate separately. So here, let's calculate 3 over 4 minus 1 over 4 will be 1 over 2. It will be negative 1 over 3 plus 2 over 4, which is 1 over 2. and plus the other terms 3 over n plus 3. 3 minus 2 n plus 3 will be 1 over n plus 3 minus 2 over n plus 4. And you say, okay, 1 over 2, if you use common denominator, it will be minus 2 plus 3, 1 over 6 plus 1 over n plus 3 minus 2 over n plus 4. Now we check for the problem. Let's say for n or n1. For n1, it will be what? It will be r equals 1 and 1. 1 over 1 plus 2, 3, 3 times 4 times 5 will be 1 over 60. For n equals 2, it will be 1 over 60 plus 1 over 2, 4 times 3 times 5. Let's check 4, 4, 5, 6. And it will be what? 120. And it will be 120, 2 plus 1, 3. It will be 1 over 40. So for n1, n2, it is this. Also, you can check, for example, for n1. If we check, it will be 1 over 6 plus 1 over 4 minus 2 over 5. And you can see if we consider 30, 5 over 6, 6, 5, 30, 60. It will be 10 plus 15 minus 2 times 12, 24. It will be 25 minus this. 1 over 60, let's check. We will see the first one is correct. For n2 also, if we check, it will be 1 over 6 plus 1 over 5 minus 2 over 4, which is minus 1 over, let's check, 2 over 6, which is 1 over 3. So we use common denominator 5, 3, 30. It will be 5 plus 6 minus 15. It will be negative 4 over 30, which will be negative 2 over 15. Let's check it again. 1 over 6 plus 1 over 5 minus 2 over 6. It will be negative 1 over 3 if you consider 30. Here it will be 10. Let's correct this part. It will be negative 10. 11 minus 10, it will be 1 over 30. And if we check the answer here, it will be 1 over 3 over 120, 1 over 40. Okay, for n2, let's check it again here. 1 over 60 plus 1 over 4 times, here it is 2. So you say 2 over this, 1 over 60, and 1 over 60 plus 1 over 60 is 2 over 60. It will be 1 over 30. So we see this formula is correct for all n, or n greater than equal 1. Also, in some solutions, you can ignore this part to check n1 and 2. I wanted to just teach you why it is correct for all terms. Now here the problem says, suppose from r equals 1 to infinity. So the terms here we found was this. Control C. So if we consider this term, now if we consider n goes to infinity, then here it will be 0, here it will be 0, and 1 over 6 is left. So the answer of this part equals 1 over 6. Cambridge Assessment International Education 2021 A-Level H2 Paper 1 Problem number 6. A curve C has equation y equals 1 over square root 4ax minus x squared where a greater than 0. Sketch C and give the equations of any asymptotes in terms of a where appropriate. So if we want to draw the diagram, we can say, okay, if we consider these 4ax minus x squared, it will be x 4a minus x. So it is 0. If it is 0, we want to find asymptotes x 0 or x equals 4a. So it's 0 here and it is x. You consider 4a, and if we draw dotted lines here And now here it is y. Now I want to find, I differentiate from this 4ax minus x squared. It will be 4a minus 2x equals 0. Then 2x equals 4a and x equals what? 2a. So if I consider x 2a, it will be what? This equation, it will be 1 over 4a 2a, 8a squared minus 4a squared, which will be 1 over root 4a squared, which will be 1 over 2a. And it will be something, for example, like this point. And as you can see, this is a quadratic function, and if you consider only this, because it is negative, it will be something like this. So this point that we found is maximum of this. So because it is in the denominator, it will be minimum of this. So the diagram will be something like this. So our asymptotes will be x equals 4a and x equals 0. Now let's solve part B. So we have two vertical asymptotes. So part B is what? Part B says find smallest possible value of y in terms of a. So it is this 1 over 2a. Part C, describe the transformation that maps the graph of C onto the graph of y equals this. So let's consider the first one is, let me copy this one. Paste it here. Okay, so if we consider this one, you can write it as 1 over, let me call the first one f of x equals this. You can say it is negative x minus 2a squared. So let's see what we have. Negative x squared, negative 4ax, negative 4ax. Here you have 4a squared. Negative 4a squared will be plus 4a squared to cancel that. Now, here, if you see, if I want to consider this, it is what? It is f of x. If I consider f of x plus 2a, then we will have what? We will have 4a squared and replace x with x plus 2a. It will be negative x squared, and it is exactly the things that we wanted if we consider gx. So the transformation from f to g is that is shifting f or main curve 2a units to the left. Cambridge Assessment International Education problem number 7. A level H2 2021 paper 1. It is given that y equals e to the power of sine negative to the power sine to the power of negative 1x for 1, or let's say better, inverse of sine x for x greater than negative 1 less than 1. Part A shows that 1 minus x squared times d2y over dx2 equals x dy over dx plus y. So at first we consider dy over dx is what? It will be e to the power of inverse of sine x times, we should differentiate from inverse of sine x. Okay, if we differentiate from that, it will be 1 minus x2. Now we know this. Let's find d2y dx2. If we differentiate from this, it will be to the power of inverse of sine x, 1 over 1 minus x2 times 1 over 1 minus x2, differentiate from this times itself, plus e sine negative 1x. Here it is 1. It is 1 minus x to the x squared to the power of negative 1 over 2. It will be negative 1 over 2, 1 minus x squared, this minus 1, which will be negative 3 over 2, and differentiate from this will be negative 2x. And it will be what? It will be, if we cancel these two and negative negative, it will be x to the over 1 minus x squared root 1 minus x squared. And here, if we simplify that, it will be e sine negative x 1 minus x squared, and it will be 1 plus x over root 1 minus x squared. Now, let's consider the first part. First, left-hand side. Left-hand side is 1 minus x squared times this will be e to the power of sine minus x times 1 plus x over 1 minus x squared. And the right-hand side is what? X times this part plus y. So it will be x times this will be x over root x times dy dx, and the right hand side it will be x over root 1 minus x squared, here e power of inverse sine, plus y. Y is what? E to the power of inverse of sine x. And we can see these two terms, left hand side and right hand side, are equal. Part B, find the first four terms of the Maclaurin expansion of e to the power of inverse of sine x. So it will be what, if I consider, for example, it is f of x, it will be f of 0 plus f0 plus f prime 0 over times x over 1 factorial plus is double prime x squared over 2 factorial plus the last term, it will be x cubed over 3 factorial. So let's consider, we know the first one, f of 0 is what? If you replace here with 0, e to the power of 0 is 1. So it is 1. And f prime 0 is what? F prime 0 is dy dx. Replace x with 0, it is 1, 1. So again, it is 1. And okay, for this one is d2y dx2. d2y dx2, it is this. If we replace x with 0, it will be 1, 1, 1 plus 0. So again, it will be 1 because it's 1, 1, 1 plus 0 over 1, which will be 0. It is 1, it is 1. So it is also 1. But now we should find this d3 x dx3. So let me copy this one, because I want to find d3. It is what? d3y dx3. So I differentiate from both sides with respect to x. It will be what? Negative 2x d2y dx2 and plus 1 minus x2 d3y dx3 plus differentiate from this at first dy dx plus x d2y dx2 plus dy dx. If we replace, we want to find for 0. Here it will be 0, here it will be 1 for x 0, and it will be what? d3y dx3. dy dx is 1, in x 0 it is 0, and dy dx is again 1, so it equals 2. So it is 2 this part, and the answer will be 1 plus x 2 over 2 plus, if 2 and 3 factorial, 2 and 2 here will be cancelled, plus x cubed over 3. Also, it has another terms, Maclaurin expansion, but the problem says only find the first 4 terms. Cambridge Assessment International Education A Level 2021 H2 Paper 1 Problem number 8. The lines L1 and L2 have these two equations respectively, where lambda and mu are parameters. Part A, find the Cartesian equation of the plane containing L1 and the point 1, negative 3, negative 1. Okay, so we have this line L1 if lambda is 0 is 3 to 0 this point, and this point is 1, negative 3, negative 1. So if we connect these two things, then if we cross product, for example, suppose it is T1, if we cross product, then we can find, let me show this one, with, for example, T1 L1 will be N here, if we cross product T1 L1. So T1 is what? You should say, okay, T1 means this vector. 1 minus 3, negative 2, negative 3, negative 2, negative 5, negative 1 minus 0 will be negative 1. If we consider cross product between this and L1. L1 is what is, if we want to consider this vector, 2, negative 3, 1. And we should cross product these two vectors. Okay, so for this one you say negative 5 times 1, negative 5 minus product of this will be 3, negative 5 minus 3, negative 8. And for this one, here you say negative 1 times 2, negative 2 minus negative 2 will be 0. And last one, you say negative 2 times 3, negative 3, 6. 6 minus 10 will be 16. Okay, now we know that because n is perpendicular to any vector here, so if we want to find a point here, x, y, z, we know what? We know that this n, if you consider a scalar product or dot, it will be 0. So if I consider x minus 3, y minus 2, z dot n is what? Is, you can factor from 8 and you can say negative 1, 0, 2. It should be 0 because 8 times this should be 0, so it should be 0. Now we can conclude negative x minus 3 plus 2z equals 0. So we can say negative x plus 2z plus 3 equals 0. And it is Cartesian equation of this plane. Part B, show that L1 is perpendicular to L2. So we should prove L1 dot L2 equals 0. So L1 dot L2 equals. So we consider here what? This one, 2, negative 3, 1. 2, negative 3, 1 dot 1, 2, 4. 1, 2, 4 equals 2 times 1, 2, negative 3 times 2, negative 6, plus 1 times 4, 4, 4 plus 2, 6 minus 6, 0. Okay, part C, first part. R1 minus R2 is perpendicular to L1 and L2. State the position vectors of the points where common point, common perpendicular meets L1, L2. So we should find these 2 points, R1 and R2. So R1 minus R2, because it is perpendicular to L1 dot L1 equals 0. R1 minus R2 dot L2 equals 0. We should copy the R1 and R2 here. Okay, if we replace R1 minus R2 equals what? We can say R1 equals 3 plus 2 lambda, 2 minus 3 lambda, and 0, it will be lambda. And R2 equals what? Equals negative 4 plus mu, 1 plus 2 mu, and negative 3 plus 4 mu. Now, if we consider R1 minus R2, it will be what? It will be 2 lambda minus mu, 3 minus 4 plus 7. And then it will be negative 3 lambda, negative 2 mu, 2 minus 1 LV1. Lambda minus 4 mu and plus 3. It is this. Okay, it's this one. Now let's consider From first one, it is dot L1 is 0. L1 is what is the vector 2 minus 3, 1 equals 0. So 2 times, let's consider the coefficient of lambda at first. 2 times 2, 4, minus, so let me write like this. 4, negative 3 times negative 3 plus 9, 1 times 1 plus 1 plus mu. Now let's consider it will be negative 2 plus 6 negative 4, and the constant term will be 14 minus 3 plus 3 equals 0. So here we simplify 4 plus 9 13 plus 1 14. 6 minus 4 minus 2 is 0, so 14 lambda equals, for negative, if you take it to right hand side, equals negative 14, so lambda equals negative 1. Now we should try to find mu. You can also replace lambda with negative 1. Let me replace this. It will be negative 1, negative 2, 7 will be 5, negative mu plus 5. Negative 3 times negative 1, 3 plus 1, 4, negative 2 mu plus 4. And here lambda is negative 1 plus 3, 2, negative 4 mu plus 2. Dot what? Dot L2. L2 is what? 1, 2, 4. So it will be 1, 2, 4 equals 0. Now, from here, if we consider the coefficient of mu, it will be negative 1, negative 2 times 2, negative 4, negative 4 times 4, negative 16. Constant term 5, plus 4 times 2, 8, plus 2 times 4 plus 8 equals 0. Now here it will be what? Negative 21. 5 plus 8, 13 plus 8, 21. So if you take it to right hand side, then negative 21 over negative 21, mu will be 1. Okay, now the problem says what? Mu is 1, lambda is negative 1. The problem says find R1 and R2, find value of, okay, we found this part, lambda and mu, and state the position vectors of the points where the common perpendicular meets L1 and L2. So from here we can conclude, let me write rest of that with black. This one, we said lambda is negative 1, 3 minus 2 is 1, 2 plus 3 is 5, and it's negative 1. Mu is 1, so it will be negative 3, 3, and 1. Now, in second part of C, it says find the length of this common perpendicular. So we should say R1 is this, R2 is this. Let me copy this part. Then we consider R1 minus R2 and we find the length of this vector. So paste here. R1 minus R2 is what? So you say it's this point R1 minus R2, the length of that. At first we should find the vector. It will be 1 minus this will be 4. 5 minus 3 will be 2. And minus 1 will be negative 2. And if we want to find the length, it will be square root of 4 squared 16 plus 2 squared 4 plus negative 2 squared is 4 equals negative 24. Or we can say it's 4 times 6, 2 root 6. Cambridge Assessment International Education 2021 A Level H2 Paper 1. Problem number 9. A function f is defined by f of x equals ex cos x for x greater than equals 0 less than or equal pi over 2 using part A using calculus. Find the stationary point of f of x and determine its nature. So because it's stationary point, then we can say f prime x equals 0. So if you consider, it will be ex cos x minus ex sine x equals 0. So we can divide both sides by ex because it is not 0. So cos x minus sine x equals 0. Then we can say, okay, cos x equals sine x, and then we can say if we divide x is between, you can imagine the unit circle, but let me tell you, draw and consider it, that which of them is not 0. It's between 0 to this point. So cos can be 0 here, sine can be 0 here. So if we consider this unit circle, for these 2 points, for example this one, cos x is what? Is 1, sine x is 0. For this point, cos x is 0, sine x is 1. So we can say x is strictly greater than 0, less than pi over 2. And then you can, for example, divide both sides by cos x. We know it is not 0 because it is equal to this. So equals tangent x. And we can conclude that x equals pi over 4. So for this point, it is a stationary point. And so if we want to find exactly this point is what? Pi over 4, and e to the power of pi over 4 cos pi over 4, which is root 2 over 2 e to the power of pi over 4. Okay, and if we calculate this, if we want to show this with calculator, it will be 0.78, for example 5, and this point will, and this one will be 1.55. So the problem says determine its nature, its maximum or minimum. Look, if it is maximum, it is negative, and if it is minimum, d2y dx2 is positive. So if I consider f double prime of x equals what? Equals ex cos x minus differentiate from this, differentiate from this. Okay, ex sine x, and this one will be negative ex sine x, and this one will be negative ex cos x. And okay, so if we consider for x0, f double prime 0 will be what? Will be cos 0, because e0 is 1. Cos 0 minus sine 0 will be 0. This is also 0. Negative cos 0. Sorry, x is pi over 4, so let me erase this. So e, for all of them, we have e to the power of pi over 4. And we know cos pi over 4, sine pi over 4, they are equal, so you can say they will be cancelled. And this one, each of them is e pi over 4 root 2 over 2. So you say negative 2 root 2. Okay, and it is positive, positive, negative, negative. So it will be this case, and this point is maximum point. Okay, part B, integrate by parts twice to show that it is equal to this. So here we want to solve this. I consider the first one equals f prime, for example this one g. So it will be equal to fg. Let me write e2x cos 2x dx equals fg will be e2x over 2 cos 2x minus, so minus fg prime. F is what? F is e2x2. G prime will be 2 negative 2 sine 2x. So it will be e2x over 2 cos 2x. If we simplify, these two will be cancelled. Negative, negative will be positive. It will be e2x. Let me write dx. Sine 2x dx. Again, here we consider this one f1 prime, this one, for example, g1. So here we write at first this one e2x over 2 cos 2x. Plus f1g, it will be e2x over 2 sine 2x minus this part that equals f1g prime. It will be e2x over 2, and g prime will be 2 cos 2x dx. Okay, and here again we can say, okay, it is, let me call this one, for example, a equals what? A equals, these two will be cancelled. If you pay attention, it is also a, again, negative a. So 2a equals e2x over 2 cos 2x plus e2x over 2 sine 2x, and a will be what? You can say it's plus c, because we can have constant here. So a will be 1 over 4 e2x, or you can add c at the end if you want to have exactly this c, or here you can say e, for example, t, that t is constant, and then t over 2 is c. So cos 2x plus sine 2x plus c. Part C, the graph of y equals f of x is rotated completely about the x-axis. Find the exact volume generated. So you can say the volume equals pi integral from, okay, so let's check this. It says x is between 0 and pi over 2. So you say from 0 to pi over 2 f of x squared dx. Now, if we replace, it will be from 0 to pi over 2. And if we consider from 0 to pi over 2, ex cos x. So we place ex cos x dx. Here we found it is what? For 2 e2x. So here, if you consider, it is squared. So if we want to consider this one, it will be what? Pi over 2, 0 to pi over 2 e2x. But here we have cos 2x, cos squared x. So we can replace it with what? We can replace it with cos 2x. Let me write e2x, cos 2x plus 1 over 2 dx. Now, if we divide it to different parts and take 2 outside, it will be pi over 2 from 0 to pi over 2 e2x cos 2x plus e2x dx. So we can say it's pi over 2. Let's write e2x cos 2x. We know e2x cos 2x integral is 1 over 4. Let me copy this part, copy, and we can paste it here. It is this, and this one will be what? Will be e2x over 2, and x is from pi over 0 to pi over 2. Now we can say, okay, it's pi over 2, the first one, from pi over 2. It will be pi, sine pi will be 0, cos pi will be negative 1. So it will be negative e to the power of pi and over 4. And this one will be what? Plus e to the power of pi over 2 minus, we replace x with 0. It will be 1, it will be 0. And cos 0 will be what? Will be 1, 1 over 4 minus 1 over 4 plus, you replace x with 0, it will be 1 plus 1 over 2. If we simplify, let's see what we have. We have pi over 2, this minus this will be e pi over 4, and minus 1 over 4, it will be negative 3 over 4. Okay, we can say it is equal to pi over 8 e pi minus 3. Okay, Cambridge Assessment International Education A Level H2 2021 Paper 1 Problem number 10. Scientists model the number of bacteria N present at the time T minutes after setting up an experiment. The model assumes that at any time t, the growth rate in the number of bacteria is kn for some positive constant k. Initially, there are 100 bacteria, and it is found that there are 300 bacteria at time t equals 2. Write down and solve a differential equation involving n, t, and k. Find k and the time it takes for the number of bacteria to reach 1000. Okay, so because the problem says the growth rate in the number of bacteria is kn, so you say dn over dt is kn. Now we can conclude, because here is dn, take 1 over n dn here and k dt here. If we consider here antiderivative, it will be what? The left side will be ln of absolute value of n, because we know growth rate is kn and k is positive constant, and at first we have 100 bacteria, so we can say it's ln of n equals kt. If we raise kt plus a constant, if we raise both sides e to the power of each side, e to the power of left hand side will be n, and right hand side will be akt plus c. So you can say it is ekt times ec, it is constant. Suppose it is c1, so it is c1 ekt. Now we know the problem says initially means t0, n is 100, so if you consider 100 equals c1 e to the power of 0, 0, so c1 is 100. From this one, we've concluded it is 100 ekt. If t equals 2, we have 300 bacteria, so we can say 300 bacteria equals 100 e to the power of t is 2k. So we can divide both sides by 100, so e2k is 3. So we can say 2k is ln of 3, so k equals ln 3 over 2. Now if the problem says what? The problem says find k, so here it is this, and we can write it equals 0.549, and n will be what? 100 e to the power of kt. K is this, so you can say it's lkt or ln of 3 over 2 times t. And so the time it takes for the number of bacteria to reach 1000. So if we consider it is 1000, so one answer was this. Next answer, we consider this one. Then we say, okay, if we consider ln from both, it is e to the power of this. And if we divide both sides by 100, then it will be what? ln 3 over 2t equals 10. Then if we consider ln 3 over 2t equals ln of 10. So t equals 2 ln of 10 over ln of 3. And the answer equals 4.192. Or you can only write until this part. 4.19, and okay, this part we've answered all the things that it wanted. The rest of the problem says the scientists repeat the experiment again with an initial number of 100 bacteria. The growth rate Kn for the number of bacteria is the same as that found in part A. This time they add an antibacterial. Okay, we have antibacterial solution, which they model as reducing the number of bacteria by d bacteria per minute. write down and solve a differential equation giving t in terms of n and d, hence find n in terms of t and d. Okay, for this part, we say dn over dt equals kn, the growth rate, minus reduced by d minus d. Now it's write down the differential. We've done this. So now we want to find n in terms of t and d. So we can say if we consider 1 over kn minus d, dn equals dt. So here we can say if we use an antiderivative, we can say what? We can say ln of kn minus d. It must be positive because the number of bacteria, each the growth rate. Because if you subtract d from that, you should have something. It is positive. And then we can say what? And at first we start from 100. Okay, so let's solve this one. Let me tell you something here. We said this. Also, you can, it's n is this. You could also say n equals, it is okay. You can say e to the power of ln 3 is 3. You could also say it's 100 times 3 to the power of t over 2. You can write like this if you want. Here we say, okay, ln of kn minus d equals t plus c. So if we consider e to the power of them, it will be kn minus d equals e to the power of t. Let me write like this. And then you say, okay, e to the power of c times e to the power of d. You can consider the first one is c1. C1 ET. Now we conclude what? Kn minus d equals C1 ET. And here, because we integral, we have coefficient k, so you should write over k, and then it will be kt plus c and ekt plus kc. So we consider, for example, we can say, okay, it's kt plus kc, so it will be kc here, and you call this one c1 e to the power of kt. Now we can conclude what? Kn minus d equals c1 e to the power of kt. Okay, so we can conclude n equals what? C1 ekt plus d all over k. And we know this k is the k of previous part, that initially we have 100 bacteria. So we can say if we consider t0, n should be 100. Now we say, okay, 100 times k. K was what? ln3 over 2 here. We've reached that in previous part. Equals c1 e to the power of 0 is 1 plus d. So we can find c1 in terms of d. It will be c1 will be 50 ln3 minus d. So if we replace n will be what? 50 ln3 minus d e to the power of ln3 over 2t plus d all over ln3 over 2. Now, if we simplify the first term, we can write e ln3 over 2t to the power of ln3 will be 3 to the power of t over 2. So let's see what we have. Okay, so if we simplify, we multiply 2, it will be 100 ln3 minus 2d over ln3, and it is 3 times 3 to the power of t over 2 plus 2d over ln3. So we found the formula of n. Part C, first part of that, find the range of values of d for which the number of bacteria will decrease. So here, if we consider dn over dn by dt is kn minus d. So because we want to decrease kn minus t. In previous part, we consider kn minus t is positive. So if here it's this, so you should only change the sign of ln. It will be in the thing inside ln. Kn is less than d. So we can say what? We know that kn is what? ln 3 over 2. So let's replace that. So this times n, d should be greater than this. And in this case, you can say, okay, if you have this case, if you want to use ln, you should consider ln of d minus kn and do all these things again and only change that sign. So it was first part of C. Okay, for second part, in the case where d equals 58, find the time taken for the number of bacteria to reach 0. So here we consider this part again until here. Let me copy. Okay, so this time, because we want to d is greater, because we want to reach 0, we know d is greater than kn. I told you, if d is greater, solve like this. So ln of this equal over k equals t minus c. You multiply by k, ln of d minus kn equals kt plus kc. You consider, for example, this c1. Here, let me write, it's, for example, okay, this c1 is different from previous one, because here the sign is different. So let me write, instead of cd, then it is d1. So if we e to the power of them will be d minus kn equals e to the power of kt plus d1, which equals e d1 times ekt. You can consider e d1 d2 is constant ekt. And then, okay, we have this, and we can conclude that if you take it here, n equals d minus d2 ekt all over k. So we consider we want to find d2. We say, okay, for t0 we know n is 100, and for k also equals ln 3 over 2. So 100 times ln 3 over 2 equals small d, which is here 58, minus d2 e to the power of 0 is 1. So d2 equals 58 minus 50 ln 3. Now we can find n. n is what? Is 58 minus 58 minus 50 ln 3. It is d2 e k is ln 3 over 2 times t all over what? ln 3 over 2. So we can consider n is this. The problem says what? For what t n equals 0, reach 0, the number of bacteria. So if n is 0, then we conclude 58 minus this, the numerator will be 0. 58 minus this is 0, so we can say, okay, 58 equals 58 minus 50 ln 3 e to the power of ln 3 over 2 times t. Then you can consider e ln 3 over 2t equals 58 over 58 minus 50 ln 3. And then if you consider ln from both sides, we will have ln 3 over 2t equals ln 58, 58 minus 50 ln 3. And here, if you use calculator, you can find this, and ln of that times 2 over ln 3. T will be 5.35. Cambridge 2021 Assessment International Education to 2021 H2 Math Paper 1, problem number 11. Civil engineers design bridges to span over expressways. The diagram below represents a bridge over an expressway PS here. In the diagram, PQ and SR. PQ, this one, and SR are parallel to the y-axis, so we know it is 90 degree, 90 degree, and PQ equals RS. Okay, the arc of the bridge QR, this part, forms part of the curve OQRC. Yes, OQRC with parametric equations x equals a times theta minus sine theta, y equals y a times 1 minus cos theta for theta greater than equals 0, less than or equal to pi, where a is a positive constant. The units of x and y are meters. At the point Q, theta equals beta, so here theta equals beta, and at the point R here theta equals 2 pi minus beta. And find, so here you can check, for example, if theta is 0, it is 0, 0, x will be 0. So you can understand that theta here is 0, and for this one here C, because it is until 2 pi, theta is 2 pi, and you can find exactly it is what, for example, a 2 pi minus sine 2 pi will be 2 pi a, 2a pi. And okay, so find part A, find in terms of a and beta the distance ps. So we should find x of s minus ps is what? X of s minus x of p. So x of s related to x of theta, that theta is 2 pi minus beta minus x of p, which is x of beta. So if we replace here, it will be a times 2 pi minus beta minus sine 2 pi minus beta, which is minus sine beta. And on here, because it's 2 pi minus beta, you can ignore 2 pi, it is minus beta, so you should write plus beta. And minus a beta here, and minus sine beta. So if we factor from a, we have 2 pi minus beta, 2 pi minus 2 beta, plus sine beta will be 2 sine beta. You can factor from 2, it will be 2a pi minus beta plus sine beta. Part B, show that the area of the shaded region on the diagram representing the area under the bridge is this. So let's see, let me copy this shape here, copy, okay, paste it this part, and also we know x is what, y is what, and it's from we said in the picture theta here is 0, theta here is 2 pi, so we can paste this part here. Okay, so here we want to find the area shaded region. We should say, okay, it is equal to y dx. X is this, so if we differentiate dx with respect to theta, it will be what? It will be a1 minus cos theta. So if I want to, I should consider antiderivative from beta, evaluate from beta to 2 pi minus beta, it will be beta 2 pi minus beta. Y is what? A times 1 minus cos theta. Dx is what? Is a times 1 minus cos theta d theta. So we should calculate this. It will be what? It will be beta to 2 pi minus beta a squared, because a is constant. You can factor from a squared, and it will be a squared 1 minus cos theta squared d theta. Okay, here we say, okay, we expand, it will be a squared beta 2 pi minus beta 1 plus cos squared theta minus 2 cos theta d theta. So we consider each of them, it will be what? A on. Here I write, instead of cos squared theta, 1 plus cos 2 theta over 2. And then I can say what? The first one, a squared So we have 1 plus 1 over 2, 3 over 2, 3 over 2 theta, and then cos 2 theta will be negative sine 2 theta, or plus sine 2 theta over what? Over 4, because also we have 2 here, minus 2 cos theta, which will be minus 2 sine theta, and from beta to 2 pi minus beta. Okay, now let's calculate this. It will be what? It will be a2 3 over 2 pi minus beta will be 2 pi minus 2 beta plus sine 2 times this, sine 4 pi minus 2 beta minus sine 2 beta over 4 minus 2 sine beta. Let me write here in this fraction 2 sine 2 pi minus beta. You can replace it with 2 sine beta and minus 2 sine beta. They will be cancelled. And okay, so here you can say it is 0. What about this? Sorry. Here it's 2 psi, and 2 psi not pi minus beta, it is 2 pi minus beta. So you can say 2 sine. This one will be negative. 2 pi minus beta is minus beta, is negative sine beta. So you can write this, and also the next one will be minus 2 sine beta. So it is this part. We don't have any fraction here. So let's simplify. It will be a squared 3 pi minus beta, and 4 pi minus 2 beta will be sine negative 2 beta negative sine 2 beta. So it will be negative sine 2 beta over 2, because we have 2, and minus plus 4 sine beta. Okay, so let's see. We should prove what the sentence of the problem that we should prove. If I copy, let's see, it is what? So if we factor from 1 over 2 here, 1 over 2 a squared, here we multiply by 2, 6 pi minus 6 beta, and minus sine 2 beta, here we have minus sine 2 beta plus 8 sine beta, and it is equal exactly the thing that we wanted to prove. Part C, it is given that the area under the bridge in square meters is 7.8159 a squared. Find the value of beta. From part B, we've proved that the area is this, so we write 7.8159 a squared, and we can cancel a squared. And then if you solve this equation, beta equals 1.89 and radian. Part D, the width of the expressway PS is 50 meters. Find the greatest and least heights of the arc QR above the expressway. Okay, so PS, the problem says we proved from previous part PS is this, PS 50, we replace 50 to a pi minus 1.89 plus sine 1.89. Okay, so if we want also find more exact figure, is 1.8913, around that. If you calculate with calculator, then we will see that if we calculate this, it will 11,367. And so we found A. The problem says find the greatest and least heights of the arc. So it is the least, and this one is greatest part. Okay, so the least of height of this arc we consider QP, so we should consider y of beta. And the greatest one is y of this one, which is from 0 to 2 pi, it is 4 pi. So y of pi if you use the formula from assumption. Okay, so we can say y beta is 11,367 1 minus cos theta, and it will be 1 minus cos beta, which is 1, 8, 9, 13. Okay, so it will be, if you calculate, it will be around 1495. And if we calculate for y of pi, it will be 11 times 367, 1 minus cos pi. Cos pi is -1, so it will be 2. And we can calculate this, it will be 22,734. So we found the maximum height and minimum height of this problem. I will release other years, other papers of A-level Cambridge assessment, also other exams. If you had any question about the solution, feel free, as I said before, to send message to my WhatsApp number in the description and comments. Also, subscribe my YouTube channel and turn on the bell to have next video.